Here we're looking at a factorisation method called difference of squares, or sometimes called a difference of perfect squares. If you look at this expression 9x squared minus 16, we can see that we've got two parts to it. 9x squared is the square of 3x, and 16 is the square of 4. And we've got a difference, or a subtract sign, between those two terms. Now let's go back to a notion of factorisation for any expression. The first thing we always do is look for a common factor. In this case, no common factor exists between 9x squared and 16. The next thing we do is we say, okay, it doesn't fit any particular description with a common factor, or it's not a trinomial. Let's look to see if it is a difference of squares. And as mentioned before, 9x squared and 16 are squares of terms, in this case 3x and 4 respectively. What we then do is we split up the 9x squared minus 16 into two different brackets. The first part of the bracket contains 3x, which of course squares to 9x squared. The second part of the brackets contains 4. And those two terms in the two brackets are separated by a plus in one bracket and a minus in the other. Now the order of those plus and minus signs doesn't matter. So you could have 3x minus 4 and 3x plus 4, and that would still be correct. Let's check to see what happens when we multiply out those brackets. We can see here from this expansion that we multiply out the 3x by itself, and the 3x by a negative 4, and the 3x by a positive 4. Those two terms in the middle of the expression will cancel each other out. And then we've got 4 multiplied by negative 4 at the end. Here's a simplification of that expansion with the 12x, which results from the product of 3x and 4. And then with the simplification, we're back to our original expression, which is 9x squared minus 16.